It's amazing. NASA has now revealed the first photographs of planets so bizarre that they contradict our preconceived notions about life in the universe, and the James Webb Telescope delivers the image we have all been waiting for. Will we find life on 2007-010, a dwarf planet that hovers at the solar system's very edge and exhibits enigmatic signs of life in the complete darkness of the Kuiper Belt for the first time in the universe? When OR10 was originally spotted, in 2007, it was a scientific miracle since scientists never thought they would find another planet this large, so far away in our own solar system. With a diameter of about 1,135 kilometers, this dwarf planet has caught the interest of the scientific community. It is one of the largest known dwarf planets in our solar system, and evidence of a surface rich in complex organic compounds was found in 2007-010. The James Webb Telescope is essentially destined to analyze a distant and nearly dark world like 2007-010 in great detail. It misses nothing. According to experts, this world was discovered by astronomers using the Samuel Ascent telescope at the Palomar Observatory. Its slow rotation of about 45 hours and its remote location in the Kuiper Belt make it one of the most mysterious objects we know. Now scientists want to use their new wonder weapon to reach the bottom of the planet. James Webb's new space telescope is already regarded as a legend, although it is merely a technological marvel that humanity has built over many decades. This most powerful telescope in history has cost $11 billion, but we already know that it is worth every cent, because since its launch in the summer of 2022, the telescope's first images are challenging our preconceived notions about the Big Bang. It took a lot of laborious and creative work to finally solve the last great mysteries of the universe. We must radically reconsider the age and the finiteness or infinity of the universe, as our beliefs on the origin of matter and the evolution of galaxies were most likely incorrect. We saw images of black holes that were so massive and large at the beginning of time that they could not possibly exist according to our outdated astrophysics. The Webb also showed us galaxies that were so old and perfect that they could not possibly fit into a young universe. As a result, we must reconsider and be open to a whole new way of thinking. Planets like 2007, 7, and 2010 served as a reminder to science that we still don't know everything. And ever since the internet was created, we have had to face the fact that we don't actually know much about the cosmos. James Webb's enormous 6.5 primary mirror and cutting-edge infrared equipment give it exceptional technical capabilities that surpass any prior telescopes. Because of its exceptional sensitivity, the Webb can see into the most remote and darkest parts of the cosmos and can consistently identify light sources that are 13.5 billion years old, nearly as old as the universe itself. Webb can reveal hidden stars and planets by penetrating thick dust clouds that prevent other telescopes from seeing them. With its advanced infrared sensors and spectroscopic instruments, the James Webb Telescope is an invaluable tool for astronomy. With its ability to observe the universe in unprecedented detail, it is opening doors every day to discoveries that will fundamentally change our understanding of the cosmos. What will Webb find on 2007-010? With his near-infrared spectrograph and mid-infrared instruments, Webb could analyze the surface composition of this distant celestial body in unprecedented detail, allowing him to identify the chemical fingerprints of the materials present. A potential spectrometer image could give us fascinating insights into which complex organic compounds are actually present here and what story they will tell us. Researchers believe that these compounds, remnants which were made visible by the interaction of UV light with methane and other simple organic molecules, are what give the planet its distinctive tint. Thins are of particular interest for astrobiology as they are considered to be building blocks for more complex organic molecules, and would therefore be a basic building block for the development of life. Substances such as these have already been found in the vicinity of several moons in the solar system, which are also hot candidates for the first discovery of extraterrestrial life. Their presence on celestial bodies such as 2007-010 could indicate that the moons and dwarf planets played a previously unknown role in the origin of life in the solar system. These compounds could give us clues about how organic material forms and evolves in the outer solar system, and we gain important clues about the chemical and physical conditions in the early solar system. In addition, Webb could confirm the presence of water ice and other frozen substances that indicate the geological and climatic conditions on the dwarf planet. In addition to these incredible traces of life, 2007-010 has another secret concerning its very existence. The planet's orbit has not yet been fully confirmed, which is why it does not have a proper name and is only listed with a provisional catalogue number. So far, the details of its exact orbit and physical properties are truly shrouded in mystery. With careful observations and long-term monitoring, the telescope could more precisely track the planet's orbital movements in the Kuiper belt and determine its rotation period. This information would be crucial to calculate the planet's orbit with greater accuracy. And once the International Astronomical Union's requirements are met, the planet will finally receive its own official name, Webb, on the trail of the mysterious rogue planets. 2007-010 is so far away from us that observation with previous telescopes was only possible under very difficult conditions. Have you ever heard of rogue planets? These are free-roaming planets in space that, as demonstrated by the 2007-10 incident, are very challenging to research in the expanse of interstellar space. The planets are little, but they do exist. Without a doubt, occasionally scientists are able to find these planets, but as soon as they are captured, they vanish into the immense blackness of the cosmos and are never seen again. Even these elusive planets can be found and studied by the James Webb Telescope. Advanced infrared instruments can detect even the low thermal intrinsic radiation of rogue planets, which have no light source of their own and travel outside the luminosity of stars. However, even these planets emit a small amount of radiation because of internal processes and their motion through space, which we can detect with the help of sophisticated instruments like Webb's. This amazing development will enable researchers to examine the characteristics and makeup of these free-floating planets for the first time, leading to a better understanding of the formation history of free-orbiting planets. Webb's precise analyses could also help determine the number and distribution of rogue planets in our galaxy. Researchers suspect a certain regularity in these phenomena, and if we can determine how frequently and in which region of the universe they occur, we will have added another piece of the puzzle to the overall picture of our cosmology. Webb's accurate analyses will enable us to uncover the internal structure and even potential geological activity of even the smallest thermal emissions from 2007-10 wandering planets that exhibit signs of geologic processes and active cores. Since we first started studying the cosmos, it has repeatedly demonstrated to us that nothing is impossible. Awesome. We are all familiar with Neptune, the cold, deep blue ice giant at the outer edge of the solar system. But have you ever heard of ultra-hot Neptunes? We have a fascinating new class of exoplanets that are genuinely unique, and we would never have found them without our enormous advancements in observational technology. These planets are similar to Neptune in composition, but they orbit very close to their stars, often much closer than Mercury orbits our Sun, and as a result, their surfaces can reach extraordinarily high temperatures of over 1700 degrees C. These harsh circumstances utterly upend accepted beliefs about planet creation and evolution, and give rise to a variety of other fascinating phenomena. The surface of ultra-hot Neptunes is so heated that it can split. Extreme temperatures can cause atmospheric escape, in which the planets lose their gases as a result of strong stellar winds and intense radiation, converting gases like hydrogen, helium, and methane into atomic components. Kelt 9b is a prominent example of an extremely hot Neptune, with a temperature so high that molecules like water cannot exist in a stable state and instead decompose into atomic hydrogen. The existence of ultra-hot Neptunes challenges our understanding and compels scientists to create new models and theories because, in accordance with conventional theories, such planets should not exist and would have to be destroyed during their formation or due to their extreme proximity to their stars. These planets present a singular chance to investigate the mechanisms of atmospheric escape and planetary migration in harsh environments. With its advanced infrared equipment, the James Webb Telescope is currently playing a vital role in the research of extremely hot Neptunes. Webb can also investigate the composition of the atmospheres and identify whether molecules are truly present or absent in the surroundings of extremely hot Neptunes. Webb can also research the thermal radiation and spectral signatures of these planets in detail. This information is essential for comprehending the chemical reactions that occur in such harsh environments through the use of infrared spectroscopy. Webb readily enters these planets' atmospheres and recognizes the distinct chemical traces. This enables researchers to use long-term data to map the distribution of atoms and molecules and investigate the impact of powerful stellar radiation. In addition to providing detailed monitoring of these planets' atmospheres and icy losses, Webb can also help us better understand the mechanisms of planetary migration. By determining the rate and extent of atmospheric loss, we can better understand how these planets came to be so close to their stars and what processes kept them there. This helps scientists improve their models of planet formation and evolution, and gives us more insight into the various physical and chemical forces in the universe. Since Webb's launch, scientists have suspected that there may be other forces in the universe that have not yet been identified, but could be crucial to comprehending the big picture. With the JWST, we have the greatest secret weapon to solve. These mysteries and every odd and unexpected discovery provides us with a clue to these forces. Sign up for a subscription now to ensure you never miss a new video highlight.